Hi everyone, I'm Matt from THKP, and today I want to share my favorite UI pattern with you. It's something I'm going to call multi-swipe, but admittedly I'm not 100% sure that that's its name because I haven't been able to find other references to this UI pattern. I originally saw this in the collaborative inbox app Missive, which, by the way, if you need to manage a shared inbox across a team, you should definitely check them out. They're not sponsoring this video or anything, I'm just a fan. Anyway, Missive has the typical swipe interaction that you're all familiar with, but they also have kind of a nifty trick up their sleeve where while you're dragging one email, if you drag down or up from that email, it'll bring that email along for the ride, providing a really smooth and powerful way to manage a bunch of emails with a single swipe. Today, I'm going to show you how you can implement this in your app using Flutter. But even if you're not using Flutter, I recommend considering this user interaction for your app. So we're going to be starting with a very simple stateless widget. So the first thing that we're going to do is create a stateful widget, which represents the home, and we'll call this list view. And since we're using a null safety, we need to tell them that key can be null here. We're going to get right down to it, and instead of this being a container, we'll make this a list view. And we just have a very simple utility to create a tile item, which just accepts an integer, which you'll see why in a bit. And the reason we're not seeing anything is because we're not using this list home view as our body yet, so let's do that. Okay, so we see our list items, and these are just columns of text, and I think what we will do is put a little bit of padding around them, and we'll say this is the contents of the tile item. We'll also wrap this in a simple container. And then the height of these tile items is actually going to be a known quantity and something that we'll use to implement the multi-swipable. So we'll store that in a constant up above. Also, just to make it clear where the border between one item ends and the other begins, we'll add a divider here. And actually, we may need to do one minor thing, which is to make space for our divider here. Okay, so this is kind of the core foundation on which our app is going to be built. We have our list items here, and I think the next thing we should do is try to make one of these list items swipeable. So let's get into that. We are just going to wrap a single one of these tile items in our kind of infrastructure to make it swipeable. One of the core aspects of that is going to be a gesture detector. And before we can actually make the gesture detector do useful things, we're going to need to set up some state. The way we're going to track changes to the draggable state for one of these items is by using an animation controller. Using an animation controller is going to allow us to make certain types of animations a little easier going forward. So that's what we will do. We'll call this drag controller. And we are going to need to initialize this in our init state. If you've watched any of our videos before, you'll know we need a with single ticker provider state mixin. In our gesture detector, we will add an on horizontal drag handler. Okay, so we're doing the updating half of this implementation. So when we drag this, we are setting the value on drag controller, but we actually need to modify the list item. And the way we're going to do that is with a transform. Okay, we will need to refresh our app. since we don't have the drag controller state, nothing is happening, and that is because we need to wrap all of this into an animated builder. And now this immediately pops because we were dragging this before and it just immediately does the translate. And so we see we can drag this around. We do have a couple of issues. One is if we drag on the white part of this widget, it does not move. And also, as you can see, it will just hover in midair, essentially, partially dragged when we let it go. So we want to address both of those issues. The first is because our gesture detector by default only handles taps on opaque parts of its child. So we need to update the behavior. So let's just see. So now we can drag this from anywhere. And as well, we want to reset the position of the item when the user lets go. So we will add a similar listener here. On drag end. All right, so when the user lets go, it snaps back to the beginning. So as you can see, we're already starting to get a decent bit of the way to getting this kind of swipeable behavior, even with a relatively simple set of widgets. For the next part, we're going to start to implement the multi-drag behavior, where you start the motion by dragging to the left, but then in the case that you drag down, you'll start to affect the location of all the items underneath it. So let's get into that. The first thing that I think it makes sense for us to do is, instead of just having this literal list of widgets in here, for us to hold a list of quote-unquote email items in our state, and then generate this list of widgets from that list of email objects. So let's start doing that. Okay, so this is our new email state. We just generated the list of events from 0 to 19. And now we will add a new private method, which is a get list items. So now we have these list items, and when you drag one of them, all of them move because they're kind of in an undifferentiated way, just transforming their state along with every other child. So this kind of makes sense. Let's do one other thing. We'll say that its tile item is email sub I. Just so we can differentiate. The other thing to note is that even though we do have a horizontal gesture detector listener, our vertical scrolling still works fine. So the next part to this solution is we need to keep track of which item is being dragged around and only move the item that is being affected. So we will store the start item. Let's call this dragged IDX. Okay, so now that we're recording which item actually triggered the drag, what we can do is say, before applying the transform, we say, oh, is, I equals dragged IDX question mark. So if the index of the item that we're generating is the same as the current dragged index, we'll only move that one. And so now each one of these is a draggable item. Now that we have a way of applying this transform to only one item, we can actually now start to calculate, okay, the user started by dragging this index, and now they've dragged to this lower or higher index, so we should also apply this drag controller value to all of these indices. So what we're going to do is calculate the offset from the dragged index, as mentioned before, using what we know about the height of one of these elements, which is 50 device agnostic pixels. Okay, just to unpack this a little bit. So the deets.local position is the offset that this tap occurred with respect to the widget that it occurred on. So for example, let's say we tap on this widget, it's going to treat 0, 0 as the upper left-hand corner of this widget, and it's going to say, okay, well, maybe this tap occurred 25 pixels down and 180 pixels in from this top left corner of this widget. So the way that this works is if we're anywhere within this item, the dy of this tap divided by the list item height and then taking the floor of that will equal 0. And that just means that only the dragged index should move. But then when we get to the next item where it's greater than 50, we divide by list item height and then floor that, it's going to be 1. So we know we should include list item and then one more. And then this also works in the other direction, where if this starts to go negative and we divide that by list item height and then floor that, it's going to be -1. So we know we should use dragged index and then one item above it. So that's kind of the rationale behind calculating this drag offset. So now, for the purposes of deciding whether or not we need to apply this translation, what we're going to do is calculate the top index and the bottom index using the dragged index and the offset. So we'll say top IDX Also, while we are at it, we should be zeroing these out. Dragged index IDX. All right, so just to review again what we're doing, we're calculating how many list items we've crossed when we are dragging down. And we are looking at those when we're building each one of these items, and we're deciding, oh, okay, so should we be dragging this item? So let's take a look at how this works. Okay, this is not working right now, and I think we may need to set state on the offset as we're dragging around. Oh, we do seem to have some error. We just need to have a semicolon. So now we see that when we drag down, all of these items are responding in accordance with whether or not our user's mouse is atop them. So the next step is just going to be for us to start to show a little action widget to the left of our dragged items, so the user knows what action they're going to perform. In order to build our swipe action indicator, we're going to introduce a stack to our widget tree. And what this will allow us to do is draw a little rectangle that fills the newly available space, kind of opened up by the swiped items. So let's do this. We'll wrap this in a stack. And we're gonna introduce a new method called getSwipeActionIndicator. And we are going to return a container that's kind of positioned in such a way that it fills that space. And I believe we are storing all of the items necessary to calculate what the bounds of that rectangle should be. Let's just start off by doing something simple though. Return. Okay, so super simple, but basically if the person is swiping to the right, it'll be green, and if the person is swiping to the left, it'll be red. So let's give this a shot. All right, and now we get this differentiation depending on which direction the user is swiping. But we also want a little icon which indicates what the user is doing. So let's add that to this container. And as you can see, since we're just filling up the whole space in the background, this icon is just floating in the middle of the container. But we want it to be nicely positioned in the middle of that space. So we're gonna have to do a slightly more precise job of positioning this container. I think what we should do though is to split this into two positioned according to whether or not they're swiping to the left or the right. So let's say if we'll move this up above. So to get this to be centered in the horizontal direction, it's actually fairly straightforward. We will say that from the left edge, it should be 0. And then the width is just going to be the drag controller dot value. All right, so now we can see our little icon is horizontally centered, and then this should work on the other side as well. But the centering it vertically is going to take a little bit more doing, but it's kind of similar to what we had to do before to determine which one of these items we need to translate. So let's take some of this logic here about how to calculate the top and the bottom indices. And we want to calculate pixel values because that's kind of the language that Positioned is speaking here. So we'll just say top pixel offset. And these are still in indices, but we know how we can translate between indices and pixels because we know how tall one of the items is. And this is going to need to be a double. And then another thing I want to point out here is that this bottom pixel offset will need to add 1 to this index here, just because even if we only have a single index, that bottom is going to be 50 pixels lower than the top. So we just add 1. And we obviously want to double check that these values are not null. There's a slightly interesting relationship here. So the top is top pixel offset, But bottom is the distance from the bottom, whereas bottom pixel offset is just the distance from the top. In our case, what we can do is say that the height is the bottom pixel offset minus the top pixel offset. Okay, and let's just do that to the bottom as well. Great, so now we have our centered icon for our swipe action indicator. Oh, okay, right, and this is the problem. This is what happens if you try to use a bottom pixel offset minus top pixel offset as bottom instead of height. So let's fix that. So this is looking good, but we actually have a pretty serious issue that when a user scrolls down, it really messes with our logic for where these things should be positioned, because these positions aren't taking into account that this could be scrolled at all. And this just kind of always exists behind this scroll view, taking up 100% of the space, but it doesn't move at all when we scroll. What we need to do is take into account how much this list view has scrolled, and then use that to calculate our top pixel offset. So we will add a scroll controller, maybe next to our animation controller. And we're going to pass this into, let's just see, we should need to initialize this. And list view accepts a controller as an argument. And I think we're going to need to refresh. Now, as we scroll around, scroll controller should be updating the offsets here. One case we need to handle is sometimes the scroll controller cannot be attached yet. So we'll say scroll controller. So if the scroll controller isn't attached to the list view yet, we return a container. And so the way this is going to work is we just need to subtract the amount that the scroll view has been scrolled from these top pixel offsets. So we'll say all these values minus sc.offset. Oops, scroll controller.offset. Same thing here. So this still works on our unscrolled case, but then importantly, when we scroll, it still works there too. We're getting really, really close to our final goal. I think the last thing we should do is just add the ability to, when the user lets go, depending on some threshold we set, we will either animate the items out and remove them from the list, or we'll slide them back. So let's get into that. Here is where using an animation controller to control this swipe action is really going to pay off. I think the first thing we should do is animate this item so that it snaps back when the user lets go, instead of, or well, so that it kind of gradually animates back instead of just instantly popping back. Let's go to the on drag end handler. Okay, on horizontal drag end. And we're going to pull the contents of this into another function just so it's a little neater. Instead of immediately setting the value to 0, we're going to want to animate this value. So we say drag controller dot animate to, and we'll set a duration here. And we'll set a curve as well. Whenever I don't know what to do, I just set it to ease in out. And in addition, we don't want to set the values of these to null until after this animation is complete. So we're going to create another status listener function on this class. We'll say and now we will set this as an animation status listener. And then the last thing we're going to want to do is remove this status listener once it's done. So we'll say drag controller dot remove a status listener. Now we should be animating these values back. Okay. We have a very simple issue here. Okay, so we need to stop setting the value directly to 0 so that the animate to can actually work. Okay, and this seems like it's working fine. The last thing we need to do is make it so that if this is greater than some threshold, we animate the items away and then we remove them from the list. So we will set a threshold, an action threshold here. And just to explain kind of how to reason about this, it just means that if the user swipes this item more than 20% of the way across the screen, we'll accept their action and then we'll swipe it all the way across. And in our animate drag end, we're going to want to check if they've dragged it farther than that. We're going to need to grab the width of the screen. All right, let's swap these just to make it slightly more reasonable. So if our drag controller value is less than the screen width times the action threshold, we're going to want to make this the absolute value because it can be negative. If the absolute value of the drag controller value is less than the screen width action threshold, we will do the same thing that we were doing before. So we'll say, else we will check which direction the user is dragging it. So we'll say drag controller.value. So if we're dragging it to the right, so if they're dragging it to the right, we want this item to be moved all the way over so that it's the value of the screen width. So we will say and now in the other case, when it's less than 0, we want to animate it to negative screen width. And then finally, we're going to need to do a similar thing where we do a little bit of cleanup once the animation is over. So let's start to implement that. And now, as the name indicates, we're going to remove the items that are currently being dragged. And we want to reset the value of the drag controller to 0 so that the next time we drag, we don't start from all the way over to the left edge. So let's calculate this value. And we will remove our items from the list of emails. And we're adding +1 here because remove range is not inclusive for the second index. So we just had one, because at least the way we were calculating this is inclusive of the last index that's being dragged. Okay, now let's give this a shot. So after we're doing all this, we need to set this as our animation listener. And then we need to remember to remove that as the animation listener once this is finished. So all right, let's take a look. So let's confirm the slide back still works. And then so we are not nulling out these values correctly. We also need to remember now to set the animation state to 0. Our action listener is not updating. Once we let go, it doesn't continue along with it. So all we should need to do is update our swipe action indicator and wrap it in an animated builder. Okay. Right, and there we have it. So this is going to complete our nicely animated multi-select implementation. So obviously there are a couple more edge cases that we could handle better, but this is kind of the main thrust. And in addition, we could say, for example, animate the rest of the items up in a cleaner fashion. But I think for the purposes of this video, this really gets 95% of the way there. Thank you for taking a look, and I hope you have a great rest of your day. Thanks for checking out this tutorial, and keep an eye out for future videos from THKP. If you found this useful, give us a thumbs up. And if you're interested in seeing more, don't hesitate to subscribe.